Everyone, my name is Ferial and I'm computer science graduate student at the University of Oklahoma. The title of my project is Time Limited NFT Membership with Gasless Renewal. In this project, I built a complete smart contract system on Ethereum that allows user to mint an NFT based membership. Each membership has a set expiration time. For example, 30 days and can be renewed later. If the membership expires, the user can still renew it. The smart contract also supports gasless renewal using a standard called EIP712. This means the user signs a message off-chain and the relayer sends the transaction on-chain and pays the gas. This is useful for new users who don't have Ethereum or don't know how to use a wallet. To make the system more secure, I use role-based access control. Only admins are allowed to change important things like the price of membership. Admins can be granted or removed using a script we wrote called manage_role.py. The project also includes full support for meta transactions which follow EIP 2771, a standard using a separate forwarder contract. All the interactions were tested and confirmed on the Sepolia testnet using Brownie and Web3.py. What makes this system unique is that it is very simple to deploy and easy to extend. It does not use a complex proxy contracts like Unlock Protocol or SDK like Lead. It is designed for smaller communities like student groups, DAOs, or research labs that want something lightweight, cheap, and self-managed. This is not just a basic NFT, it has real functionality like expiration, gasless renewal, admin control, and meta transaction support, all in clean and efficient design. Many online communities today want to control access to their content or even like a private group or research club or small DAOs. Usually they use simple website or central tools, but these are not transparent and they depend on third-party platform. There are existing Web3 protocols like Unlock or Lead, but these systems are often too complex for small groups. Unlock users many smart contracts and proxies, and Lead focuses on encrypted off-chain data and needs SDKs. These platforms are powerful but not easy to customize or deploy. My goal was to create simple and affordable solutions, something easy to use even by a student or non-technical users. For example, a student club could give NFT access passes that expire in 30 days. Member can renew them without paying gas just by signing a message. Admins can control pricing or access rules securely. This system is designed for real-world situations where groups want control, flexibility, and low cost without needing to be a blockchain expert. The technical architecture of this project include two smart contracts, which are NFT membership and minimal forwarder. The NFT membership contract is an ERC721 token that includes an expiration system. Each minted NFT has a field called valid until, which stores a unique timestamp of when it expires. User can renew their token before or after it expires, and the contract automatically update the expiration. To support gasless renewal, the contract also include a function called meta renew membership. This function can only be called by the trusted forwarder, which brings us to the second contract. The minimal forwarder is based on EIP 2771 and it allows meta transaction. The user sign a message off chain using EIP 712, then a relayer takes the signed message, sends it to the forwarder and pay the gas. The forwarder checks the signature, checks the notes, and then calls the actual renewal function, passing the original user address. In this setup, the user never sends a transaction directly, the relier does, but the contract still knows who the real user is by extracting it from the message. For security, the NFT contract user role-based access control. Only user with admin role can change the membership price. Role can be assigned or revoked on chain using our brownie script. This architecture is simple, modular, and gas efficient. It avoids unnecessary complexity like upgradable proxy contract or multi-contract factories used by the protocols. In this slide, I will explain how Gasless renewal work in my system using EIP 712 and EIP 2771. First, the user wants to renew their membership NFT. Instead of sending the transaction and paying gas, the user just signs a structure message off chain. This message includes the function they want to call, in this case, a meta renew membership, and some other fields like their address and the gas limit and the token ID. The message is signed using EIP 712 format, which ensures the signature is secure and standardized. Next, separate service or relier, which can be run by the community admin, takes this signed message and sends it to minimal forwarder contract. The forwarder checks the signature valid and that the nonce has not been used before. Then the forwarder appends the original user's address to the call data and calls the NFT membership contract. Even though the relier is paying the gas, the contract still knows who the real user is because the sender's address is encoded in the message. This way, only the true owner of the NFT can renew it, even if the relier is the one submitting the transaction. This approach is fully compliant with EIP 2771 standard, and it allows new user to interact with the contract without having it earn valid. This process was tested on the Sepulia testnet using my Gasless Renewal.py and relier execute.py script, and the event logs confirmed that everything works as expected. Let me start by showing the smart contract that powered this project. This is the main contract called NFT membership.soul. It is built on the standard ERC721 token, but I added feature called valid until, which store the expiration date for each NFT membership. User can call mint membership to create a new membership that lasts for a set number of days. They can also call renew membership if their membership is about to expire or already expired. For Gasless renewal, the contract has a special function called meta renewal membership, which allow a relier to submit the transaction on behalf of the user. To protect sensitive functions like setting the membership price, I added role-based access control. Only account with the admin role can call membership set membership price. Admins can be added or removed using grant admin role or revoke admin role. Now here is the second contract, which is minimal forwarder.sol. This contract support EIP 2771 and handle meta transaction. It received a signed message from the user, verifies the EIP 712 signature, and then calls the NFT contract as if the user had sent it directly. This setup lets user interact with the contract without holding any ETH, or which is helpful for beginners or small communities. Now I'm demonstrating the role-based access control system in the NFT membership contract. In this script, I grant the admin role to an address. In this case, you can see this one, and this is done on chain using the function grant role, and the transaction was confirmed in the block 8252823. Brownie prints the message that the role was successfully granted, and I verify it by checking has role, which returned true. Then I immediately revoke the role using revoke role. The revocation was confirmed in block 8252824. Finally, I confirm that the address is no longer has the role because the has role returned false. This proves that only account with default admin role can assign or revoke admin privileges, and that the contract enforce securely using OpenZeplane access control module. Deployed the minimal forwarder contract, which handle gasless meta transaction using the EIP 2771 standard. It verifies the user's signature and forwards the request to the main NFT contract. The contract was deployed successfully on the Sepolia testnet at this address using about 489,000 gas. I will use this address next to deploy the NFT contract. This step, I deployed the main NFT membership contract, which manages minting, expiration, and renewal of membership NFT. The deployment was successful on the Sepolia testnet, confirmed in the block that you can see in this block, and use about 1.9 million gas. The contract was deployed to this address, and it's now ready to be used in the rest of the system, including gasless, renewal, and admin controlled pricing. In this step, I ran a mint membership.py script to mint a new NFT membership. The transaction was confirmed on the Sepolia testnet in this block, and it used around 81,000 gas. The minted token includes an expiration timestamp stored in the contracts valid until mapping, which allows the system to track when the membership will expire. This confirms that the contract is working correctly and ready for renewal. In this step, I used test renew.py script to renew the NFT membership by calling the contract directly. The transaction was confirmed in this block, and use about 32,790 gas, which is efficient for renewal that updates the expiration timestamp. This confirms that the user can successfully extend their membership by paying the fee, and the update expiration is stored on chain. The membership renew event was also emitted, confirming the function executed correctly. In this step, I ran Gasless renew.py script to prepare Gasless renewal. This script used EIP712 to generate a secure structured message that includes the function called data, the user address, the gas limit, and the nonce. It signs the message using my private key and saves the signed request as signed request.json. This file will be used by the relayer to submit the transaction on behalf of the user, allowing the user to renew Windows without spending any ETH. Okay, in this part, I use relayer execute.py script to submit the signed gasless request on behalf of the user. The signed request was read from signed request.json, and the relayer called the minimal forwarder, which verified the signature and forwarded the transaction to the NFT membership contract. The transaction was confirmed in this block, and using about 64,000 gas. This shows that Gasless renewal is working end to end. The user did not pay gas, but their membership was successfully renewed. As you can see here, the status of the renewal of the membership was successful. Okay, in this step, I ran the data analysis.py script to fetch and analyze membership renewal event from the blockchain. It connected to the Sepulveda network and scanned the block where I expected a renewal to happen. This script successfully found two membership renewed event for token ID 1, each with a new expiration date. This confirmed that both direct and gasless renewal were recorded on chain, and that the contract's event emission and state tracking work as expected.